Today we're going to discuss problem solving using involving estimation of parameters, and we're going to use Excel to solve problems. For the sources of this book, all images from this book in this presentation are from the Untitled Chapter presentation, and all problems in this book are found in in this presentation. In this book, Modern Business Statistics with Microsoft Office Excel, and we're going to use Microsoft Excel to solve the problems. So in interval estimation or estimation of parameters, there are two types: your interval estimation for population mean and your interval estimation for population proportion. So let's start with interval estimation for population mean. So in your confidence interval for the population mean, you have this 1 minus alpha times 100% as your confidence interval. And you have the following confidence interval estimates. Okay, so you use different values for point estimate plus minus margin of error. So the values here subtracted and added to your point estimate for population mean, which is a sample mean, are called the margin of errors for the following conditions. So condition 1, when sampling from a normal population with a known population standard deviation, we use this formula. Condition 2, when sampling from a normal population with a known population standard deviation and your sample size is less than or equal to 30, we use this formula. And when sampling from normal population with a known population standard deviation and sample size greater than or 30, we use the same formula, this formula. So for the first condition, that's mean plus minus z alpha over 2 times sigma over square root of n. For condition 2, that's mean plus minus t alpha over 2 times sample standard deviation divided by square root of n. And for condition 3, that's sample mean plus minus z alpha over 2 times sample standard deviation divided by square root of n. Okay, so let's proceed to your problems. So for problem 1, the National Fire Protection Association reported that house fires in the United States result in 6.8 billion in losses annually. National Fire Protection Association, September 2015. Suppose a random sample of 50 house fires in San Antonio yield a mean loss of 18,503. If the population standard deviation is sigma equal to 3,300, what is the margin of error for a 95% confidence interval? What would you recommend if the study required a margin of error of 300 or less? 300 or less. Okay, so let's go to your conditions. So since na-identify that there is a population standard deviation, so the sigma is known, we go with your 1 or condition 1. Okay. So using this Excel, you can plot out actually all the portions or all the parts of the formula in this manner. So first is the point estimate, which is the sample mean. So the sample mean is 18,503. That is your mean loss. Okay, so we plot out here 18,503. Then Z alpha over 2, since our confidence interval is 95%, so this is actually equal to 1 minus 0.95. That's 95% divided by 100. So 0.95. So 1 minus 0.95 is 1.05. Or 1 minus 0.05 is 95. 0.95. So this is now 0.05. And then we divide this by 2 because it's z alpha over 2. So divided by 2. So that's 0.025. Then in your z table of values class, you'll find the z value, which is equivalent to 0.025. Okay, so in this case, that's 1.96. So this is now the intersection, so 1.96. So our z alpha, or at least our z alpha is 1.96. And the population standard deviation is 3,300 as mentioned here in the problem. Sigma is 3,300. Okay, the sample size is 50. Okay, then using this formula, we solve for the margin of error. So the margin of error is z alpha over 2 times sigma over square root of n. So we solve for the square root of n, which is the square root of 50. Then the margin of error is now equal to alpha over 2, which is z alpha over 2, which is 1.96, times sigma, which is 3,300, divided by your square root of n. Divided by your square root of n. Okay, so these three are chosen and then equal. So the margin of error is now 914.71. Okay, 914.71. So I'll answer the question. What is the margin of error for 95% confidence interval? So the answer is 914.71. And then to get the interval estimate, you simply have point estimate minus your margin of error and point estimate plus your margin of error. Okay, and then you can also say that you are 95% confident that the true value of the population mean is between 17,588 to $19,417. Okay, so that's your conclusion. And then for this recommendation class, what would you recommend if the study required a margin of error of 300 or less? So this problem actually involves this portion of the interval estimate, which is to solve for the sample size for estimating your population mean using your margin of error. Okay, using your margin of error. So if you want to have a margin of error of equal to 300, you have to find out if the sample size should retain or you have to change that one, especially if all the other factors are known. Okay, so let's go to that one. Now, I have also already plotted it actually here, but let's do that again. Okay. So, to solve for the sample size using a given some margin of error, so in this case, our z alpha is 1.96. The population standard deviation was 3,300. The margin of error that you need is 300. So, using that one, we use this formula. N is equal to quantity z alpha over 2 times sigma over margin of error, quantity squared. Okay. So let's start with equal to z alpha over 2, 1.96 times your population standard deviation, which is 3,300. Then you can divide this value by the margin of error that you want, which is 300. And finally, we get the square. The square. So we use the power. Okay. We identify this one. And the power is 2. Raised to 2. Okay. And so the sample size is now 464.8336. Okay. So it's now 464.8336. Okay. So using that one, instead of 50, you use 464 or 465. So let's have 465 as your sample size. Okay, then using everything else, so we solve for your margin of error. So first we get the square root of 465. And then using everything, so this is now 1.96 times sigma, which is 3,300, divided by the square root of n. And let's close this one so that it Don't be confused later. So now your margin of error is 299, okay? Which is smaller than 940. So for your recommendation, that is to increase the sample size. Recommendation is to increase the sample size for this problem. Okay? Then let's have problem 2. The Wall Street Journal reported on several studies that show massage therapy has a variety of health benefits and it is not too expensive. A sample of 10 typical 1-hour massage therapy sessions showed an average charge of $59. The sample standard deviation for a 1-hour session is S is equal to 5.50. What assumptions about the population should we be willing to make if a margin of error is desired? Using 95% confidence, what is the margin of error? And using 99% confidence, what is the margin of error? This problem is actually altered by me because I had a hard time looking for a problem involving sample standard deviation with a sample less than or equal to 30. So let's just change this one. And let's just ignore this 95% confidence because you already solved a problem prior, which uses 95% confidence. So let's use your 99% confidence. Okay, so 99% confidence of the value. So since gin-change ni gani ang population standard deviation to sample standard deviation, meaning condition 1 is not met, and this is now using condition 2 when the sampling from a normal population is unknown, or the population standard deviation is unknown, and n is less than or equal to 30. Okay, so the point estimate here is still your mean, population mean, so the average charge of $59. So the point estimate is 59. Then since this is T alpha over 2, and we are going to use 99, so this is now 1 minus 0.99. And of course, divided by 2. And since you're using to use the T table instead of the Z table, we're going to look at 0.005 as the alpha, and your df is n minus 1. For interval estimate, the degrees of freedom is n minus 1. So using your T table, degrees of freedom, let's use the one-tailed critical value of alpha. So in this case, that's 0.005. So 0.005, this one. The degrees of freedom is 10 minus 1, so that's 9. So here, okay, these values here, and 0.005, so 3.250. So the degrees of freedom is 3.250. If you're using a different T table, expect to have some differences also in the T value. So this is now 3.250. And the sample standard deviation is 5.50. The sample size is 10. Okay. And now for the margin of error, that's T alpha over 2 times S over square root of n. So we have T alpha over 2, which is 3.25, times the sample standard deviation is 5.5 divided by square root of n. Wala ito pagili na square ang ating sample size. So let's have the square root of this one. Please, hindi siya kitaon. So for the margin of error, that's T alpha over 2 times the sample standard deviation divided by the square root of n. So our margin of error is 5.65. So to get the interval estimate, again, that's your point estimate minus your margin of error and your point estimate plus your margin of error. Okay. And then you can say now that you are 99% confident that the interval estimate is from $53.3 to $64.65. Okay, so this is now your interval estimate. Okay. And lastly, problem 3, personnel for Skilling's distributors submit weekly reports listing the customer contacts made during the week. A sample of 65 weekly reports showed a sample mean of 19.5 customer contacts per week. The sample standard deviation was 5.2. Provide 90% and 95% confidence intervals for the population mean number of weekly customer contacts for the sales personnel. Okay, so for this problem, since you already solved for a 95% confidence interval, let's solve for a 90% confidence interval. In this one, since it's a sample mean, so and a sample standard deviation, so your population standard deviation is unknown, but the sample is 65, which is greater than 30, so meaning this is condition 3 class, and we are going to use this formula, which is x bar plus minus z alpha over 2 times s whole over square root of n. So again, let's identify the point estimate, which is your mean. So the sample mean is 19.5. The z alpha over 2, we're going to use 0.90 or 90% confidence interval. Okay, so this is now 0.01 divided by 2, since it's divided by 2. Okay, so that's 0.05. So since z, so you're going to check your z value which is equal to 0.05. Okay, 0.05. So 0.05 0.05 here, 0.05 here, 0.05, then between negative 1.6, between 0.0505 and 0.0495, diba? This is plus 5 minus 5, so between the two, so that's 1.645, negative 1.645. Okay, so this is 1.645. So this is now your z alpha over 2. The sample standard deviation is 5.2. 5.2, and the sample size is 65. Okay, so again, we get the square root. Then for the margin of error, that's z alpha over 2 times s divided by the square root of n. So this is now 1.645 times s, which is 5.2, divided by your square root of n. So the margin of error is 1.06. The margin of error is 1.06. So the interval estimate is now point estimate minus margin of error, and then point estimate plus margin of error. So you are now 90% confident that the true population mean is between 18.44 and $20.56. Okay, so that's for the interval estimates for three different conditions involving your population standard deviation, whether it's known or unknown, and if it's unknown, is your sample size greater than 30 or less than 30. And you have the different computations for that one. Okay. The next, you have here your interval estimation for population proportion. So there is only one formula. So that's p hat, or you can also use p bar. P hat is your interval estimate is equal to p hat plus minus z alpha over 2 times square root of p hat times q hat all over n if p is not too close to 0 or 1, and the value of q hat is equal to 1 minus p hat. Okay, so let's have this problem. According to statistics reported on CNBC, a surprising number of motor vehicles are not covered by insurance. Sample results consistent with the CNBC report showed 46 of 200 vehicles were not covered by insurance. What is the point estimate of the proportion of vehicles not covered by insurance? Develop a 95% confidence interval for the population proportion. Okay. So for the estimate, since this is population proportion plus, it's also a proportion. So the value here now is equal to 46 divide 200 as shown in the problem. And since z alpha over 2, the problem uses 95% confidence interval, so we use 1.96 as identified earlier. The p-value or the p hat is actually equal to 0.23. So their q value is equal to 1 minus your p value, or 1 p hat. Then the sample size is 200. Let's read the problem again. According to the statistics supporting CNBC, a surprising number of motor vehicles are not covered by insurance. Sample results consistent with CNBC report showed 46 of 200 vehicles were not covered by insurance. So what is the point estimate? So that's 46 divided 200. And develop a 95% confidence interval for the population proportion. Okay. So the margin of error, that's equal to z alpha over 2 times square root of p hat times q hat all over n. Okay, so let's start first with your p hat times q hat. So you can do this step by step, or you can also do this at once class, that's also fine. Then you have p hat times q hat divided by your n, which is 200. And lastly, we have the square root of p hat times q hat all over n. So that's now 0.002. And lastly, margin of error, this is now equal to, this is p hat times q hat divided by the n, or the square root of p hat times q hat divided by the n times your confidence interval. Okay, so that's now 0.05832. It's also expected that the value is also in proportion form. Okay, since this is population proportion. And for the interval estimate, the same. We still have, this is not really equal to the point estimate minus your margin of error, and point estimate plus the margin of error. So this is now 0.17 to 0.28, or the true population proportion of vehicles not covered by insurance is between 17.17% to 28.83%. If you want to do the percentage, you simply multiply this by 100% also. Okay, so that's for population proportion. Then the next one here is sample size for estimating population mean, which we've already covered in the first example. But if you want to solve, then you can actually do this. You can solve this on your own. The U.S. Energy Information Administration reported that the average price per gallon of regular gasoline is 3.94. So that's the mean, sample mean. The US EIA updates its estimates of average gas price on a weekly basis. Assume that the standard deviation is $0.25 for the price of gallon of regular gasoline and recommend the appropriate sample size for the US EIA to use if they wish to report each of the following margins of error at 95% confidence. Okay? So the desired margin of error is 0.10, the desired margin of error is 0.07, and the desired margin of error is 0.05. Okay, so you can solve that one using this one. You can do that. Okay, or using this formula, n is equal to z alpha over 2 times sigma all over the margin of error squared. Then lastly, you have your sample size for estimating population proportion. So if p hat is used as an estimate of p, then we can be 1 minus alpha times 100% confident that the error will not exceed a specified amount e when the sample size is n. So n is equal to z alpha over 2 squared times p hat times q hat all over margin of error squared, or e squared. Okay, so let's have this problem. At 95% confidence, how large a sample should be taken to obtain a margin of error of 0.03 for the estimation of a population proportion? Assume that past data are not available for developing a planning value for P star or P hat. Okay? How large sample to the margin of error of 0.03 for the estimation of a population proportion? Assume that past data are not available for developing a planning value for P star. Okay? So since ang z alpha over 2 is 95%, so we can use 1.96. The p value is unknown. It's not given. So you can actually assume that it's actually 0.5. This is for 50%. So q hat is also equal then to 1 minus p hat. And the margin of error that you want to specify is 0.03. Then the sample size. So if your p-value is not given, you can assume that it's 0.5. So let's have this one. So first is z alpha over 2 squared. Okay, so first we square your z alpha. Then next, you square your margin of error. Then for the sample size, so this is now equal to z alpha over 2 squared times p hat times q hat. Then we divide everything with the squared value of the margin of error. Okay, so for the sample size, to have a 0.03 margin of error, then you have to have at least 1068. The sample size should be at least 1068. So you always round. Actually, you can also round off, so 1067. Anyway, 1067 or 1068 will not be much different. So that's now for the population, or how to solve for the sample size using your margin of error for population proportion. Okay, so that ends your population proportion. I hope you learned something. And for any questions, send me a message or comment below.